Hey, Wes Hanover, this is Mr. Neff here, and this week we were learning about line plots. So we have this example problem for today. It says a baker uses different amounts of sugar to make his favorite desserts. The amount of sugar for each dessert is listed below, and it's in ounces. So we have these different amounts, and we have our line plot here. So the first thing we need to decide is which one of these fractions is going to be the smallest amount, because we always want to put the smallest amount on the left and order them from least all the way up to greatest on the right. So once we decided which one is smallest, and we take a look at our fractions, we have 1/8, 1/4, 3/8, and a half, and then I see those other fractions are just repeats. I decided that 1/8 is the smallest fraction. So I'm going to put that on the left. Next, we have 1/4, which of course is equal to 2/8. And then we have 3/8. And the largest amount of sugar that's used in a dessert would be 1/2 of an ounce of sugar. So that is the largest. We'll put that on the right. So once we have labeled our line plots, then we can go ahead and organize each one of those fractions into the line plot. We'll use x's. So think how many 1/8 are there going to be, how many 1/4. I saw 3 1/8 up, and there's another one, 4 1/8, and I think I got them all. Next, we'll do the 1/4. Once again, I see 4 desserts that use 1/4 of an ounce of sugar. There's 1, 2, 3, and 4, and then the 3/8. I see 3 of them. Check, make sure we got them all. 1, 2, and 3, and then, oh, I'm glad I double checked. There is a 4th. And then lastly, the 1/2, and I see 2 1/2. All right, Charlie is playing with her bone in the background. Hey, Charlie, how about taking that somewhere else? All right, so we got all of our data organized into the line plot. So once we have our data organized into the line plot, now I want to start thinking about some of the typical questions that we get asked when we are using a line plot. And the first would be, what is the total amount of 8s? So we need to count in multiples of 1/8. There are 4 of them. So that would be 1, 2, 3, 4, 8. Next, we need to find out the total of the 1/4. Looking at the 1/4, we have 4 of them, so we're counting multiples of 1/4, 1/4, 2/4, 3/4, and 4/4. 4/4, as we know, is also equal to 1 whole. All right, third, we need to calculate the total number of 3/8. Looking back at our data, we have 4 of them. We're counting in multiples of 3/8. So counting multiples of 3. 3, 6, 9, 12. So that would make 12/8. Now notice that is an improper fraction, so you're going to need to convert that back to a mixed number. And lastly, we have our halves. There are just 2 of them, so 1 2/2. 2/2, of course, is equal to 1. All right. The next typical question that we get is, what is the total amount of, in this case, it's all the sugar in the desserts. So we need to add up our number expression here, and that would be 4/8 plus 1, or 8/8. I'm going to use 8/8 instead. Now notice I converted that to 8/8. It was at 4/4, but we know since that's equal to 1, 8 over 8, that's also equal to 1. I'm just going to convert it to a common denominator right away. 12/8. Add that to our numerical expression. Sorry about my sloppy writing. And then lastly, 1 whole. And again, I see that it's 2 halves, but instead of adding that into my numerical expression, I'm going to just convert it right away to 8/8, which is also equal to a whole. That way I can add all of these together. So lastly, let's total them up. How much total sugar goes into all of the desserts? How many 8s does that make in all? All right, I got 32 when I double check my math. Remember, you can use the commutative property to rearrange and add these in any order that you like. I like to do 12 plus 8 first, which got me 20. And then I added on 8 more to get 28. And lastly, I added 28 plus 4 to get 32. That is an improper fraction, so we need to simplify. What is 32/8 in simplest form? So we divide that 32 divided by 8. And when I divided that, I got 4 whole ounces of sugar. Again, sorry about my sloppy writing. I'm going to abbreviate ounces as OZ. All right, so we have 4 ounces of sugar in all that goes into the desserts. One of the last typical questions that we get asked is to find the average. What is the average amount of sugar that goes into one of this baker's desserts? In order to find the average, I need to take my total 4 ounces, and I have to ask myself, well, what do I do with that 4 ounces? Would it make sense to say the baker, the average dessert has 4 ounces of sugar in it? That wouldn't make any sense, because when you look at some of the data, some of the desserts just have 1/8 of an ounce. Other desserts have 1/4 or 3/8. They all have just a fraction of ounces of sugar in the dessert. So saying that the average amount is 4 ounces, which would be way down here on the right on our line plot, that wouldn't make any sense. No dessert has that much sugar in it. So the last thing we need to do then is to divide 4. What are we going to divide 4 by? That's right, we're going to have to count up how many numbers were in our data set. In other words, how many x's were there. So we had 4, and 4 make 8, and 4 more make 12. Thank you for that, Charlie. And then 2 more makes 14. So we're going to divide 4 by 14. And remember, whenever you have the smaller number as your dividend and the bigger number as your divisor, your answer is going to be less than 1 whole. So in this case, we just convert that right to a fraction and say the average has 4/14 ounces of sugar. And if we simplified that by dividing both the top and bottom numbers by 2, we would be left with 2 on the top and 7 on the bottom. 2/7 as a fraction, that makes a little bit more sense. 2/7 is right around here on our line plot, so the average amount usually is somewhere close to the middle of our set of data. All right, I hope that you did well on the Ed puzzle. And as always, if you have any questions, be sure to ask Mr. Neff.